Hi and Assalamualaikum. Here our group want to present about related rate. So let's we learn together. But first let me introduce my group members. So here I am Siti Aishah binti Irwan and my friends Amelya binti Mohd Fauzi, Amira Athirah binti Adnan, and the last one is Siti Najihah Nadhirah binti Sallizan. Here, let me start first with the introduction. So, what is a derivative? The definition of derivative can be approached in different ways that are the interpretation of tangent line and the rate of change. But we know that there are a few applications of derivative. But in this video, we will focus with related rate. So let's go through with the related rate. Related rate is the one of the most fundamental concept of calculus is the fact that derivative is used to model the change. In related rate application, we try to find the rate at which one quantity is changing by relating it to others quantity with no rate of change. The important thing you have to know, the rate of change is usually expressed with respect to time. Next, I will pass to Amelya to discuss about the objective.
Okay, now I want to explain about the objective of related rates. The objective of the related rates are to find the rates of change of two or more related variables that are changing with respect to time. Time is known as t, respect to time, which means dx over dt. Secondly, be able to find the derivative of an equation with respect to various variables. Thirdly, be able to solve the various rate of change application. Lastly, to use knowledge of derivative to solve related rates problem. Furthermore, how to solve the related rates problem? There are a few steps to solve related rates problem. Firstly, understand the problem. Identify the variable whose rate of change is known and the variable whose rate you need to find. Secondly, develop a mathematical model of the problem. This may involve drawing a picture. You can draw a picture to make you more understand. Thirdly, write an equation relating the variable whose rate of change is to be found with the variable whose rate of change are known. Fourthly, differentiate both sides of the equation implicitly with respect to time and solve the derivative that will give the unknown rate of change. The next step is evaluate this derivative by substituting values for any quantities that depend on time. You must only do this after you differentiate. The last step is interpret and solve your solution. That's all. Thank you. Next, let's see the example of related rates problem presented by Amira Athirah.
Now let's move to the related rates problem. The problem statement is a 5 feet car moves away from a street light that is 25 feet above the ground at a rate 3 feet per second. There is two questions which are, number 1, at what rate is the length of the shadow changing? Number 2, at what rate is the tip of the shadow moving? And there is an example diagram to solve the problem easily. There is height of the street light given is 25 feet while the height of the car is 5 feet. And then the rate of the car moving is 3 feet per second. So there are two separated triangles to solve the solution labeled with the numbers and unknown.
For question number 1, there is a value of dx over dt given which is 3 feet per second. And then we need to cross multiply both sides to become 25s, 5x plus 5s. And then it will become 20s equal to 5x. So we need to differentiate both sides to become 20 ds over dt equal to 5 dx over dt. Okay, and then we need to substitute dx over dt with the value given. So 5 times 3. And then it will become 15. So move 20 to the right side to become ds over dt equal to 15 over 20. And then the answer for ds over dt is 3 over 4 feet per second or 0.75 feet per second. So now we move to question number 2. There's a value of ds over dt given, which is 3 over 4 feet per second. And then on the diagram we know that x plus s equal to l. So we just substitute and it becomes 25 over l equal to 5 over s. So we need to cross multiply. And then we differentiate both sides. Become 25 ds over dt equal to 5 dl over dt. So we substitute ds over dt with the value given. It will become 75 over 4 equal to 5 dl over dt. And then the answer for question number 2 is dl over dt equal to 15 over 4 feet per second or 3.75 feet per second.
Last but not least, the conclusion of related rates. One of the conclusions is the objective of the application of differentiation are acceptable. And the second of the conclusion is the solution we use to solve the related rates problem are succeed. The answer for question 1 is ds over dt is 0.75 feet over second. And for question 2 is dl over dt is 3.75 feet over second. We can also use this way to answer another problem that related to the problem in our daily life.